In this problem, we're going to be finding the position and momentum of a particle with charge 3 times 10 to the negative 6 coulombs, mass of 2 times 10 to the negative 9 kilograms, at t equals 0.2 seconds, and an electric field given by the equation x, 2y, 3z that begins at position 1, 1, 1 with velocity 1, negative 3, 0. So we're going to be using a time step of 0.1 seconds. And the first thing we need to do is figure out the particle's momentum. How we do that is multiply its mass times its initial velocity. And we get that its initial momentum is 2 times 10 to the negative 9th, negative 6 times 10 to the negative 9th, 0 kilograms meters per second. Then we find the electric field by plugging in the value of its position, 1, 1, 1, into the equation. And we get 1, 2, 3 newtons per coulombs. Then we find the force applied on the particle by multiplying its charge times the electric field. And we get 3 times 10 to the negative 6, 6 times 10 to the negative 6, 9 times 10 to the negative 6 newtons. We're going to be using the momentum update equation, which says that the momentum final is equal to the momentum initial plus F net delta t. So we input all of those values, and we get that the particle's momentum at t equals 0.1 seconds is 3.02 times 10 to the negative 7th, 5.94 times 10 to the negative 7th, 9 times 10 to the negative 7th kilograms meters per second. And it is moving at 151, 297, 450 meters per second. Then we find its new position by using the position update equation, which says that the final position is equal to the initial position plus the velocity of the particle at t equals 0.1 times delta t. So we plug all those in, we get that the particle is at 16.1, 30.7, 46 meters. Now we need to recalculate the electric field by plugging in the new position and then finding the force applied by that new field by multiplying the charge times the new field. And we get that the force applied is 4 times 10 to the negative 5th, 9.21 times 10 to the negative 5th, 4.14 times 10 to the negative 5th, times 10 to the negative 4th newtons. Then, again, we use a momentum update equation, except this time we're using the momentum from t equals 0.1. So, the momentum from t equals 0.1 plus the F net delta t, and we get 4.93 times 10 to the negative 6th, 9.8 times 10 to the negative 6th, 4.23 times 10 to the negative 5th kilograms meters per second. And it is now moving at 2,465, 4,900, 21,150 meters per second. And I guess I chose some rather odd numbers because our particle is now moving at about 48,000 miles per hour, which is, somewhere around the particle accelerator. But we'll just work with it. So we use the position update equation again, using the new position and new momentum, and we get that the particle is now at 262.6, 520.7, 2,161 meters, which it's moved about 1.4 miles, which is about a tenth of the length of the Large Hadron Collider. So I chose some rather absurd numbers, but it all worked out in the end. Thanks for watching.